Activity 34, Modeling with Functions. Lesson 34-1, Constructing Models. Construct linear, quadratic, and exponential models for data. Graph and interpret linear, quadratic, and exponential functions. Jenna, Cheyenne, and Kim all use a photo app on their smartphones to share their photos online and to track how many people follow their photo stories. The people who choose to follow the girls' photo stories can also stop following or unsubscribe at any time. After the first 8 months, the data for each of the girls' monthly numbers of followers was compiled and is shown in the table below. Question 1 wants us to describe any patterns that we see. Well, you can see Jenna, she starts out with a pretty good number of followers and she's steadily increasing. Not too much, not too fast, but she is steadily increasing the entire time. Cheyenne, she starts out with only 2 followers, but she almost doubles every time and she ends up with a huge number of followers. Kim, she starts increasing, but then right here you can see she's decreasing. Question 2 wants us to describe those functions. Well, if you've got to remember back, we have anything that's increasing with a constant rate of change, that's going to be a linear function. So Jenna is going to be a linear. Cheyenne, she's doubling, so that's like a times 2 pattern, and that's going to be exponential. And Kim is quadratic because she's increasing and then she starts decreasing. And if we graph that, that's going to form a parabola. Use the regression function on the graphing calculator to write the equations. We've done this in the past, so what we would do is we would type in our x's in L1, our y's in L2, and then go to stat, calculate linear regression, quadratic regression, and power regression. And you can see that's where I got these 3 equations from the calculator. Approximately how many followers does Jenna gain each month justify your response? Well, if you look at Jenna's equation, she has a slope of 5. She started out with about 32 followers and she's increasing it by 5 followers every month. That's our slope. And we also consider that a rate of change, 5 followers each month. Cheyenne tells the other girls she thinks her following is almost doubling each month. Is she correct? Well, if you look at her equation, Cheyenne, it's a times 1.964 pattern. Well, that is about 2. So yeah, she is correct. She is doubling her followers. Question 6 says it wants us to use our functions to graph the 3 girls. I've done that already, actually using the table, but you could type in the equations in L1 and L2. Type the equations into y equals menu and use your table to graph. So you can see that Jenna, if we just graph that one, it's going to start about here and increase about 5 followers every month. Then you have Cheyenne. Cheyenne's going to start pretty low, and then hers ends up with a huge number of followers at the end. And then Kim, hers increases and then decreases to form a quadratic. Describe the similarities and differences between the reasonable domains and ranges of the functions. Well, the domain is going to be your x value. So we have months on our x-axis. Months can't be negative, so they have to be greater than or equal to 0. That's the same reasonable domain for all of the girls. The ranges are different. Our ranges are going to be our number of followers, so of course that can't be negative either. So most of them are greater than or equal to 0. The linear equation, it's going to keep going up. The exponential function is going to keep going up, and then the quadratic function, she reaches a max. So her reasonable range would be between 0 and 43. And you can figure out that max number right there on your calculator, or it's called the vertex, as we know. So you could calculate x equals negative b over 2a and plug that back into your function to find the y value. Identify any maximum values. Like I just said, the Kim is the only one, the quadratic's the only one that has a max right there, and it's about 43. The other ones do not have a max.